Welcome to the first video of the Cybersecurity Basics series. In this video, we are going to discuss the OSI model. You might have heard about the OSI model, but you might not know how it works in the real world or what its purpose, or how it is useful in the realm of cybersecurity. So today in this video, I'm going to discuss different layers of the OSI model, how it relates to the TCP-IP model, and what are the different layers, what are the different protocols and devices used at each layer, and how we can use the OSI model or TCP-IP model in cybersecurity. So let's get started. The OSI model or Open System Interconnection model is a process through which data is transmitted over the internet. Simply explained, it is different operations which are performed on a file when it is transferred from one location to another location in the network. So let's suppose you want to send an image to someone in America. So obviously you start with an image, but you know that the data over internet is transmitted as bits. So the process of converting an image to bits and then reconstructing an image back from those bits is all handled by the OSI model. Each layer of the OSI model performs different operations on data, and every layer represents a separate function which is performed or separate operation which is performed on the image. Several layers of the OSI model are application layer, presentation layer, session layer, transport layer, network layer, link layer, and at the end is the physical layer. These 7 layers perform different operations on the data, and every layer adds its own information or handler to the data that is being transferred over the network. Now question arises that how OSI model relates to cybersecurity. When you're working in the field of cybersecurity, you work with different protocols, and all of these protocols are explained in the OSI model and how these protocols interact with each other. You might need to manipulate different protocols at different layers. If you want to perform a man-in-the-middle attack in a network, you might need to perform ARP spoofing. Now ARP, which is the Address Resolution Protocol, is a protocol of network layer. So you cannot operate this kind of attack at the application layer. At the application layer, you will have to perform a separate type of man-in-the-middle attack, which often relates to the different protocols which are in the application layer. Therefore, it is very important to know what are the protocols at different layers of the OSI model so that we can perform our cybersecurity operations accordingly. Now let's explore every layer of the OSI model one by one. The most common layer used in the OSI model by the user is the application layer. Application layer is a point through which a user interacts with the data. Let's suppose you are browsing on the internet through a web browser. Now, web browser is an application. All the protocols used in a web browser are protocols of the application layer. Similarly, let's suppose you are interacting with a server through SSH. Again, SSH is also an application layer protocol, or FTP, or Telnet. All these protocols are basically the protocols of application layer. So these are the main protocols which user is familiar with and uses in day-to-day life. Next layer of the OSI model is presentation layer. As its name suggests, it handles the presentation of data. Let's suppose you have accessed a file using SSH, but now you want to open it in the web browser. Now, although web browser, let's suppose, is using the HTTP protocol and you have used the SSH protocol, which are two different protocols of the application layer. Although you have used two different application layer protocols, but when you open the file in the web browser, it will appear the same. It means that this is being handled by the presentation layer. Similarly, the encryption and decryption also happens at this layer. So you might have heard about HTTPS or SSL or DNS, which are encryption standards for the internet. All this encryption happens at the presentation layer. So when you receive a packet from internet, it remains encrypted starting from the physical layer up to the presentation layer. That is the reason that if you intercept a packet from using Wireshark, you might see its headers, but you cannot see the content of the packet. The reason is that the Wireshark performs the safing at network layer. At this point, the packet has not yet been decrypted completely. But on the other hand, if you are using Burp Suite, you will notice that on the transaction or on the data that you capture is in plain format or maybe in HTML format, but you can read it, right? The reason is that the Burp Suite performs the man-in-the-middle attack at the application layer. At this layer, the data has already passed through the presentation layer and has already been decrypted. So that's why you can easily see the data in the Burp Suite, but not in the Wireshark. Next layer of the OSI model is session layer. Again, as the name suggests, this layer is responsible for maintaining the session between two devices. Let's suppose if you want to send a file to my friend in USA, the first thing that happens is that my mobile and my friends in the USA, his mobile will need to synchronize with each other and they will need to establish a session. Now what happens in the session is that they will need to authenticate each other so that they can send the data securely. Moreover, from this layer onwards, the data is divided into different chunks. The benefit of dividing the data into smaller chunks is that let's suppose I'm uploading a file to Google Drive. While uploading a file, let's suppose that there is an error in my network. If the data is not divided into smaller chunks, I will have to re-upload all the file all over again. But as the data is divided into chunks, I will only have to worry about those chunks which have not been sent to the Google Drive. In this way, I do not have to resend all the file all over again. This saves not only the bandwidth, but it also saves time. These three layers we have discussed up to now, application layer, presentation layer, and session layer, are combined into a single layer in the TCP-IP model. Simply stating, the TCP-IP model is an alternative of the OSI model. OSI model is the most standardized or maybe theoretical model of the internet, but TCP-IP model is a more practical way how internet works. The TCP-IP model is few years older than the OSI model because when internet started, there was no standard model for communication between two different devices. So TCP-IP model was adopted as the practical model, but later on the OSI model was made the standard for internet. Even today, most devices operate on the TCP-IP model. Hence, you can understand TCP-IP as the practical model and the OSI as the most standard and theoretical model or the ideal model on which the internet should work. The next layer of the OSI model is the transport layer. As the name suggests, transport layer decides how the data will be transported over the internet, whether we want the connection to be reliable or we don't need it to be reliable. In case if you want it to be reliable, we use the TCP protocol, while in otherwise, we use the UDP protocol. So let's suppose if you want to upload a file to server, you don't want to lose any chunk of the file while uploading. So you want the connection to be reliable, right? In this case, you use the TCP protocol. On the other hand, let's say you want to make a video call or WhatsApp. You notice that while you are making the video call, the picture might, the few frames of the picture drop, or the sound might cut a few bits, but that does not bother you because you can, infer the information from the context, from a discussion that's going on. So you don't want to, get all the data from one side to the other side. What matters here is the speed. Let's suppose you receive all the voice and all the video in a video call, but it's keep buffering and buffering. You don't want that, right? You can afford dropping few frames in the video or few audios in the voice, but you cannot afford to keep buffering with the video. So that's when the UDP is used, where you want the speed, but you don't necessarily need all the data from one side to the other. This means that TCP creates a session between two devices, and as long as the file is transferred, the session keeps alive. And as soon as let's suppose a file or the data has been transferred, the session. And while in UDP, you don't need to create a session, you just send the data, and it does not matter whether the receiver has received the data or not. You keep sending the data. So that's how UDP achieves its speed, but there is a compromise on the reliability, of course, because you do not create a session. So how TCP and UDP relates to cybersecurity? As we discussed earlier, that TCP is a connection-oriented protocol, and it first needs to establish a session by performing a three-way handshake. This three-way handshake can be manipulated by attacker to maybe bypass the firewall, but it can also be used to perform a man-in-the-middle attack. So let's suppose the connection is established between two devices. An attacker can DDoS one device, bring that down and spoof its own IP to establish the connection with the other device. In this way, TCP handshake can be manipulated by attacker to perform different network. And the next layer of the OSI model is network layer. This layer is also called internet layer in the TCP-IP model, but the main function remains same. As the name suggests, internet or network layer is the backbone of the internet. The main protocol of this layer is the IP protocol. And you might have heard that IP address, right? You might have heard of the IP addresses. These are the addresses through which you find a device on a network. Network or internet layer also decides the route through which a data will be sent over to different locations. Let's suppose I want to upload a file on a server in Singapore. There might be 2 or 3 different network paths that can be taken by this file, but the network layer will decide which path is most appropriate, fast and reliable to send data over. This layer is also vulnerable to many types of attack, and the most common one among those is the IP spoofing. You can spoof your IP to someone else and the router will send the data to you instead of the legitimate receiver. Similarly, let's suppose I want to upload a file to a server, but the server firewall has blacklisted my IP. So what I can do is that I can spoof my IP to an allowed IP, and then I can use that my spoof IP to upload the file. Hence, IP spoofing can be used to bypass different filters and firewalls. As next layer of the OSI model is the data link layer. As the name suggests, it operates on a link between 2 different devices. The main function of the data link layer is to convert the data received from network layer into raw bytes so that it can be sent over the network. On the receiving end, the function of the data link layer is to convert the raw bytes back into frames so that it can be further processed up until the application layer. Please remember that data link layer uses MAC addresses, and MAC addresses are used to connect to a device directly. Let's suppose in a home network, you are connected to the router directly and your router knows your device through its MAC address. Similarly, your router knows the MAC addresses of all the devices. So if you want to connect to another device in your network, you do not connect to it directly using MAC address. What you do is you first provide the IP to the router. The router gives you back its MAC address, and then you connect to that device using its MAC address. You can spoof your MAC address, and this is also used in ARP spoofing, where you can spoof your MAC address and perform maybe man-in-the-middle attack over the network, or perform a DDoS attack as well in the network. So therefore, this MAC address can also be used in cybersecurity to perform different type of attack. The last layer of the OSI model from a sender point of view is the physical layer. As discussed earlier, that the main function of the data link layer is to convert data received from the network layer into raw bytes. Before passing the data to physical layer, all the necessary information has been added to the data. Every layer adds its own header or information to the data so that it can be sent to the destination IP or destination device correctly. When the data is passed to the physical layer from the data link layer, the data is already into bits and it can be sent over the network. On the receiving end, all these operations are performed but in the reverse order. The physical layer on the receiving end receives data as bits. These bits are converted into frames through data link layer. It is at this point where the error connection is performed, and if the data is not corrected, it is dropped instead of passing this data to the upper layer. Once the correct data is received, this data is passed on to the network layer, and then this network layer passes this data to the transport layer, where all the handshake, if the TCP is used, then the handshake is confirmed and it is established whether the data is in correct order or not. And if all these checks are passed, this data is then passed on to the session layer. At this point, it is checked whether the session is established, whether the data which has been received is from a valid session or not. Then this data is passed on to the presentation layer, where the data is unencrypted, and then this unencrypted data is passed on to the application layer, where it is displayed for the user. So in short, OSI model is a connection of different operations that are performed on a data when it is sent over the internet. So I hope this clears up different operations of the OSI model. If you found this video helpful, then you can like it, share it, comment below. And if you have any suggestions or review, you can also comment those in the comment section.